Now coming back to the transfer function, now continuing from the transfer function, we have to model the electrical system. Now when we talk about modeling any electrical system, basically we are talking about modeling the parameters of electrical system. So there are three parameters. One is resistor, one is inductor, and one is capacitor. We'll be seeing the different voltage and current relationship and how the transfer function for that particular model or element will look like. So first we will start with resistor. So resistor ka symbolic representation is this, and when we talk about the input voltage is equal to R into I of t, which is very common. V is equal to IR. Similarly, I is equal to क्या होगा V by R. So both the formulas represents that. Okay, this is the first basic formula. This is the second formula to find the current. Now there is one more formula which we can use. Instead of writing the current, we can write the charge. Okay, charge current is nothing but the rate of change of like flow of electrons. So we can write it as dq of t upon dt. Okay, now when we talk about the Laplace transform, if we take the Laplace transform of this particular equation, it will become R into I of s. V of s is equal to R into I of s. I of s is equal to, this will be 1 upon R V of s. So when we take the ratio of V of s upon I of s, it will come only R. So there will be no s term. So what does that mean? The resistor is a component which is independent of the frequency, which is actually true, that resistance does not has any component of frequency. So R will remain R in case of even the S domain. Okay, so that is the first thing. Is it okay? So whenever we take the Laplace transform of resistance, the value of impedance will always be equal to R. Now moving on to the second component, which is inductor. So inductor is represented like the voltage through the inductor or across the inductor is represented by L di by dt. Similarly, the current is represented by 1 upon L integration of 0 to 1 V of tau d of tau. Okay, tau is the time constant. Okay, now we are interested in knowing the value of inductor in the Laplace transform. So now when we take V of t is equal to, that there is also one possibility that it will be d of dt dq upon dt. So it will become d square qt upon dt square. Now if I take the Laplace transform, so this is how your inductor will look like, and the current flowing through it will be I of t. This is V of t. Now we took the Laplace transform, so it will be V of s, I of s, and there will be a s term which will get added over here. How this s term came into picture, let's see that. And there will be one initial current which will when we take a transfer function, we have to assume the initial current to be 0. Now how it came into picture? So it came like this. So V of s is equal to, when we take the equation, V of s will be equal to L bracket में s into I of s minus I0 minus, which is the initial condition of that particular inductor is. So V of s will become L into s into I of s. So once we take the ratio, V of s is equal upon I of s is equal to L upon L into s. Similarly, we will be deriving it for capacitor as well. So capacitor is represented by all these equations. I'm not going into detail. So when we take the capacitor, so capacitor, when once you solve it, so it will come around 1 upon C of S. So I hope it is clear. To summarize, it will look like this. In S domain, inductor and capacitor can be treated as simple impedance, which is very true, because inductor and the capacitor are only the component which has the frequency along with it, because it has the capacitance 1 upon 2 pi fc, where the frequency terms come, and xl is equal to 2 pi fl, where again the frequency terms come. So this is what you need to remember. The derivations which are done above are not that important. For numerical, you just need to remember this table. Okay. So whenever you have v of t, it will be written as v of s. I of t will be written as I of s in Laplace transform or frequency domain. R will remain as R. Inductor will become L of s, which is impedance. Capacitor will become 1 upon C of s into ohm, which is again a impedance. Now we will be seeing maybe one or two numerical based on this particular topic, so that I'll show you in the next video. Thank you.